Today we're going to learn how to install the A4988 on the MKS S-Gen L version 1.0. Now keep in mind, you may not be able to see the pins perfectly well, but for the X stepper, the Y stepper, the Z stepper, E0 and E1, what we want to focus on are the two pins right here for MS0, MS1, and MS2. And to jump these pins, what we're going to need is a jumper. So we're going to place it on the X for MS0, and then apply a little bit of pressure to put that in place. Then we're going to do MS1 and apply a little bit of pressure, and then finally MS2. Now we're going to do the same for the Y. Now we'll do MS1. Now that one's in the wrong place, so I need to pull it back out. And there we go. And then finally MS2. Now some of the things we need to know on this board are where the enable pin is located. And where I can tell you it is right here on the corner. The same for this one, the same for this one, and this one on E1. So here is the top of the A4988. Now, if you haven't noticed, I placed the cooling fins on top. That's to wick away the heat. That's that metal object that you're seeing right in the center. Now, over to the right of that, there's something called a trim pod. And that's used to adjust the current. The other things that you should be aware of are your direction pin, your ground pin over here, and then your enable pin right here. This will help you actually set up your particular configuration with this stepper. So let me point to the enable pin right here. Now, if it doesn't show up on top of your stepper, it should be printed on the bottom. Just remember that you need to rotate it into position for the enable pin to match on the MKS S-Gen L version 1.0. So now we need to place these in position. Now, as you can see, the enable pin on the right-hand side, being the A4988, shows that the enable pin is right here. So by seeing that, we know exactly where to press this down. So it's going to be placed right over the other enable pin, and then you're going to apply a little bit of pressure to get it into the configuration pin ports. So let me match this up real quick here. Now we're going to do the same with this one because we know where the trim pod is pointing, which is away from the power supply, so we're good there. So that's all you have to do to set up the steppers. Now keep in mind, if you need to attach an actual stepper now, what we're going to do is we're going to place one here. So let me zoom out a little and see if we can see this. So I'm going to move this down so it's a little bit better to see. So I have a stepper and I want to connect it to the X stepper. So I'm going to use the notched connector and I'm going to put a little bit of pressure to get that into position. Next, I'm going to do the Y stepper, which is the same exact process. So I'll just place it right here. And then I'm going to place the connection like so. So that's how we're going to set up our steppers. So to program this, what we need to do now is connect the USB serial cable, being the big side of this, to the board like so. And we need to connect the small side to the computer, and you're going to hear a beep. So the first thing I want to show you, as always, is the firmware configuration. Note the date and time. This was from the previous load. This will become relevant somewhat later. So what we need to do now is download the Marlin firmware. So I'm going to type marlinfw.org and press enter. And then I'm going to go to the download tab. And as you can see, with 32-bit versions, what we need to do is use a 2.0 version or later for loading our firmware. So I'm going to use BugFix in this case, so I'm going to download that. While that's downloading, I'm going to let you know about resources. Now, sometimes you may have a bug, or you think you have a bug, or a question. You can click here. And the cool thing is, you can ask a question right here if you'd like, and they're more than willing to answer it. Or you can basically scan through here and see if there's issues that match your own. Now, another thing you can do is click here and search on an issue like TMC 2209 and press enter. And this will show you all the issues that are occurring or possibly occurring with that configuration. So keep that in mind when you have a question that may not be within the scope of the tutorial. So let's go back, and we're going to go to the show in folder. And inside here, what I want to do is right click, go to extract all, and click extract. And while that's extracting, let you know that no one is paying me or sponsoring me to do this tutorial, and I purchased all of the equipment with my own money. But I will be placing Amazon affiliate links in the description if you so choose to buy via this tutorial. So while that's actually downloading, what I'm going to do is I'm going to go to VS Code. And I'm going to open this up as soon as the extraction has completed, so that we can see how to actually work with the firmware. So for the IDE, this is already outlined in the documentation of the first tutorial on how to install, so you shouldn't have a problem figuring it out. But what I'm going to do now is I'm going to show you how I normally set it up. Now, if you haven't been aware of this, you can go to Open Folder and open the Marlin folder for the current extracted zip. But we don't need to worry about that right now because it's already open for us. So I'm going to go to the source folder, then the core folder, then boards.h. Inside here, I'm going to search on SGen. And right here is our actual board configuration. So I'm going to copy that. Then I'm going to close out of boards.h. I'm going to close down these folders and go to configuration.h. Inside configuration.h, I'm going to do a search on motherboard. And I'm going to highlight board_ramps_14_EFB and paste what we just copied. Then I'm going to go up here and change the serial port to -1. And then finally, we have to set up our actual stepper drivers. So what I'm going to do is I'm going to do a search on A4988. And this brings us to our steppers. And the steppers that we're using are the X stepper and the Y stepper. But I'm going to show you what we do for good practice. We're going to remove the comment for the X. We're going to remove the comment for the Y. And then we're going to remove for Z and E0. These are the ones that are most used. That'll enable them for stepping. Next, we have to find our actual stepper. So down here, they have default access steps per unit. And this is for X, Y, Z, and E0, and then any other extruders that you want to add thereafter. But normally I just use the 1 instead of trying to do this nomenclature for other ones because they may vary. But for now, what we're going to do is we have to figure out what our actual steps are. So this is a little interesting. So I'm going to go back to the browser and I'm going to open a new tab and go to Rep Rap Calculator. And we need to find out how many steps we can do with this. So I'm going to go to the Rep Rap Calculator for Prusa. And inside here, if you scroll down, we're going to be working with the steppers that are on a belt-driven system. So there's 1.8 degree of step with our stepper motors. And we're using a 1/16 of a step with our stepper being the A4988. If you had something like a DRV 8825, you would probably have to double this to 1/32 of a step. And let me show you what happens when you do that. So if you scroll down here, right now it says there's 200 steps per unit when you're using a belt with a 2mm pitch or a 2mm pitch with a GT2 belt. And your pulley has 8 teeth. So this would be the actual computation that you would probably use. If it's 1/32, you can see that it jumps to 400. So now that we know that, we can go back to our actual firmware and we can change that. So the 80 will become 200 and 200 for the Y. Now keep in mind there's also a Z, and I'm going to show you that real quick. And that's based on obviously your motor, the type of stepper driver that you're using, and then in this case, this is an M8 metric rod that has 1.25 degree of step per rotation. So keep this in mind because the number is going to vary depending upon what you're using for your actual rod. So I'm going to go back because we're currently not using that. And I'm going to set up the remainder of this by going to platformio.ini. And because we're using the Mega 2560, this is not our default environment. So I'm going to change that to LPC 1768, which is our default chipset. And in order to load it, we can build it, or we can compile it and build it, and then upload it via this arrow pointing to the right. So I'm going to click on that. Okay, now that the compilation has completed, as you can see, one succeeded in 3 minutes and 31 seconds. We can double check to make sure that our chipset compiled, which it has. Now we can also double check to see on the USB drive if our firmware.bin has appeared, which it has. So I'm going to remove the USB for a moment. Then I'm going to place it back in, and this will load the current build that we're working with. And as you can see, it's updated to the current time today. So off camera, I connected the power supply for the actual power. And I have the power over here for the power supply. So I'm going to plug this in. And now what I'm going to do is I'm going to go to my desktop. Then I'm going to go to Print Run. Then click on Pronterface. And I'm going to connect to the 3D printer. And as you can see, it says connecting and printer is now online. So what I'm going to do is I'm going to move the X stepper 100 steps and see what happens. So it looks like it moved 100 steps. So now I'm going to do the Y stepper and see if it's moved 100 steps. So that appears to have worked. So if you like my tutorial, please press the like button and subscribe. And thank you for your time.